In the last video, we talked about social welfare in the face of positive and negative externalities. In this video, we're going to look at the example of driving gasoline-powered cars and their byproduct of air pollution as a negative externality. So for our example, we're going to say that 1 gallon of gasoline leads to $1 of external costs in air pollution. So that's a $1 per unit cost. And you can see over here in this market, our consumer surplus and producer surplus remain unchanged. And this red and white striped lines is going to be our negative externality. So we've already said that the government has a responsibility to maximize social welfare, but what should the government be doing in this case? Well, this is one of the cases where the government should be taxing. They can either tax the producers or the consumers. Either one would reduce the quantity of gasoline that is used and will reduce the external cost. So for our example, let's take a look at government placing a $1 per unit tax on consumers. Okay, this will perfectly offset the cost. You can see that here with the green rectangle is equal in size to this red and white striped rectangle. And we're going to go through why that is. So this tax, where our tax revenue is equal to our negative externality, is called a Pigouvian tax. And this movement in our demand curve leads to the social demand curve. Our social demand curve just means it maximizes our social welfare. So given this market for gasoline and the value of our negative externality, we can calculate the proper level for our Pigouvian tax and go through why it is $1 per unit. So we'll start by calculating the cost for externality. Here is our regular market for gasoline. Our equilibrium price was $2 and our equilibrium quantity is 400 gallons. So our negative externality at the equilibrium price and quantity is just going to be the area of this rectangle, which is $2 minus $1, right over here, $2 minus $1. And 400 minus 0. So 400 right here minus 0. So we have 1 times 400. That's the area of that rectangle, which equals 400. The next thing we want to do is find the per unit cost of that externality. So all we're going to do is take this 400, the area of our rectangle, and divide by the quantity. Okay, so we have NE, it's 400. Now we're just going to divide by the quantity, the total number of gallons of gasoline that were used. So we just want the per unit cost of our negative externality, and that's going to be $1. So we have a $1 per unit cost for externality. Now, a Pigouvian tax is going to perfectly offset our negative externality, so we want a per unit tax that is completely equal to our per unit externality. So our tax we could set at 400, we could set a tax at $1 per unit. A tax of $400 will not be a Pigouvian tax because it won't perfectly offset the cost of our externality. A tax of $1 per unit over here will work as a Pigouvian tax because our negative externality per unit is $1 as well. We can think about why this tax of 400 does not work if we think about what happens to demand when we add a tax. Okay? So if we have a decrease in demand, which happens from an additional tax, what happens to quantity? Well, let's take a look at this graph. Here's our original demand for gasoline, and then we put a $1 per unit tax, so demand shifts down $1. Okay? Now our demand curve has shifted down everywhere and our equilibrium is going to move to the left. So our quantity has gone from 400 in our original market down to 300 in equilibrium here. Because our quantity has shifted, that means our negative externality value has shifted, right? So instead of this rectangle over here, we're now looking at the value of this rectangle down here. So here's our negative externality 1 is in this market and negative externality 2 is in this market. We went from 400 down to 300. We need our tax to offset our new demand curve, so a per unit tax will offset our per unit negative externality. We know our negative externality was at $1 per unit, so if we set a tax at $1 per unit as well, we'll end up with this green area being exactly the same as this red and white striped area. What happens to consumer surplus, producer surplus, and total surplus with the new tax? I will let you all figure that out on your own. Just know that in the original market, our consumer surplus and our producer surplus are all that goes into total surplus. In our new market, with the tax revenue, we need to calculate the area of consumer surplus, our tax revenue, and our producer surplus to get our total surplus. Deadweight loss is area that is lost due to our tax. What happens to the social welfare with this new tax? So our social welfare is just going to be our total surplus plus our externalities. So social welfare in this market is going to be the value of our consumer surplus. the value of our producer surplus, and then we're going to subtract out the area of this negative externality. That comes out to 400. The value of our social welfare and our market with the tax is going to be the area of our consumer surplus, the area of our producer surplus, the area of our tax revenue, and then we will also subtract out the area of our negative externality. We should notice here is the final values of our social welfare. In the market on the left, where we don't do anything, our social welfare comes out to 400. In the market on the right, our social welfare is 450. So social welfare has increased by taxing to offset our negative externality. Thus, government has increased social welfare and done its job to maximize social welfare for its citizens by implementing a tax.